Okay, let's do question number 11. It says, what non-zero value of x is a solution to the following equation? So let's go ahead and write it down first. We've got x plus 2 over x plus x minus 6 over 3x is equal to 2x plus 9 over 5x. So this is a rational equation. Rational equation. And you can tell that it's rational because it has a bunch of fractions. So what we want to do is we want to find the least common denominator, the LCD. So what I'm going to do is I'm going to circle all of the denominators. We've got x, 3x, and 5x. And I want to find something that all of those will multiply to. Since I have a 3 and a 5, I know that I can multiply to 15. But I'm also going to need an x. So I'm going to put an x beside that. So what we can do with this is we can change all the fractions to 15x. I'm going to go ahead and do that. So for the first fraction, I'm going to have 15x at the bottom. Notice that we're taking this x up here and we're multiplying by 15. So I need to multiply the top by 15 as well. So I'm going to have 15 times x plus 2. Then over here for the next fraction, I'm still going to have 15x. But in order to go from 3x to 15x, I need to multiply by 5. So I'm going to multiply by 5 at the top. And then for this last fraction, I have 15x. That's going to be my common denominator. But in order to get to that, I need to take this 5x, multiply by 3. So we need to multiply the top by 3. Okay, so now that we've changed all the numerators, we can set all the numerators equal to each other. So at the top, I have 15 times x plus 2. We're going to simplify that later. At the top of this one, we have 5 times x minus 6. And then over here, we have 3 times 2x plus 9. So now what I'm going to do is I'm going to take whatever's on the outside and multiply it by whatever's on the inside. So we're going to multiply everything by 15, multiply everything by 5, and then multiply everything by 3. So when I do that, I get 15x plus 30. Over here, I'm multiplying by 5, so I'm going to get 5x minus 30. And then over here, I get 6x plus 27, I think. Yeah, 3 times 9. So now I've got like terms, right? I've got a 15x and a 5x. I can put those together. I get 20x. And then I can put the numbers together. 30 minus 30. Those are actually going to cancel out, so I can cross them out. And then over here on the other side, I'm going to have 6x plus 27. Okay, so now I want to get all the x terms on the left side. I need to get rid of this 6x somehow. Since it's positive, I'm going to subtract it. Minus 6x on both sides. So when I do that, the 6x is going to cancel. I can bring down the 27. And then over here, I've got these x terms combining. 20 minus 6 is going to give me 14 times x. So then the last thing that I have to do is get rid of this 14. And to do that, I can divide both sides by 14. So then if I cancel, I get 27 over 14. And I don't think I can divide that, so that's it. I'll put it in a set. So that is A. So that was a rational equation. And usually we get these by finding a common denominator, because you can't add fractions unless you actually find a common denominator first. So these two numbers have to be the same before you add. All right, let's try 12. So I've got -2 times the absolute value of 3x minus 5. And everything is equal to 0. So to do this, I'm going to have to solve an absolute value equation. And to do that, I need to get the absolute value by itself first. So to get rid of this -2, since it's being multiplied by this, I need to divide. When you divide, make sure you do it on both sides. So that the -2's will cancel out on the left side. So then I'm only left with 3x minus 5 is equal to 0 divided by -2. I think that's going to be 0. Okay, so now I have an absolute value equation. What I can do is I can take this out of the brackets like this, not changing a thing. But then on the other side, I'm going to have a +0 and a -0. Now, since a +0 is the same thing as a -0, it really doesn't matter which one we choose. I'm just going to choose 0. I get 3x minus 5 equals 0. So how can I solve this? First, I've got to get rid of the -5. We can do that by adding 5. When I do that, I get 3x is equal to 0 plus 5. That'll give me 5. And then the last thing I have to do is divide both sides by the 3 that's out in front. So the 3's will cancel, and I'm left with x is equal to 5 over 3. Now, I don't think I can divide these numbers, so I'm just going to leave it as a fraction. I'll put a box around it. And my solution set would just be 5/3, because that's the only answer that I can get from this one. Did I write the question wrong? Oh, how many values? We just got one answer, right? Okay, so one answer. That would be B. Yeah. Okay, let's do 13. For this one, I've got y is less than something, absolute value of x plus 4. Minus 1. And we can graph this. So what I'm going to do is I'm going to go to Desmos and I'm going to graph it. So over here on the left side, I'm going to have a y is less than the absolute value. You can type in ABS if you want. But what I'm going to do is I'm going to open up the keypad and find the absolute value symbols. That's going to be probably clicking ABC at the bottom. No? Okay. I'm going to click 1, 2, 3. The absolute value symbol is actually right here above the ABC. All right. So what goes on the inside? I think it was x plus 4. And then on the outside, we're going to subtract 1. So now looking at this graph, I have a V shape. I always get a V shape when I do absolute value graphs. Now for the vertex, that's going to be the point -4, -1. So when you're looking at your answer choices, you definitely want to take this into consideration. So the +4 on the inside of the absolute value tells you to move to the left 4, and then the -1 on the outside tells you to move down 1. Yep. So a couple things about this, I'll put them in yellow. The +4 on the inside means to move to the left by 4. The -1 on the outside tells you to move down 1. And then the less than symbol is going to tell you to shade downwards. That's important. You're going to want to shade downwards. So looking at the graph, we are shading below this dotted line. Another thing about it is it has dotted lines. So that's another thing. It has dotted lines. And that's because it's a less than symbol. not a less than or equal to. So we're going to have those dotted lines. So the answer is going to be B. Okay, let's try the next one. Whoops. Number 14. So 14 says square root of 7 minus 2x. That's my square root. And then plus 5 on the outside equals 8. So for this one, this is called a radical equation because it has a radical symbol. So what I want to do is I want to get the radical by itself. To do that, I've got to get rid of the plus 5. But that's pretty easy. I can just subtract 5 from both sides. So when I do that, I'm subtracting 5 from both sides. That's going to cancel out the 5 and the negative 5. And then 8 minus 5 is going to give me 3. Over here on this side, I've still got the radical. I haven't done anything to it yet, but I'm about to. So now that I've got the square root on one side, I can get rid of the radical symbol. I can get rid of a square root by doing what to both sides? Squaring, right? Now what that's going to do is whatever's inside the radical symbol is just going to come out. So I get 7 minus 2x. And then on the other side, I have 3 squared. That's going to be 3 times 3, 9. So now I can work on getting x by itself. I've got a positive 7 over here. I can subtract 7 from both sides. When I do that, the 7s are going to cancel. And that's only going to leave me with a negative 2x. And on the other side, I have 9 minus 7. That's going to give me 2. So now the last thing I need to do is get rid of the negative 2. Then the x would be all by itself. And since it's multiplying, I'm going to divide both sides by negative 2. The negative 2's are going to cancel out. And then 2 divided by negative 2 is what? Two divided by negative 2? Negative 1. So I put that in my solution set. That's going to be D. Now, sometimes you're going to get answers that actually don't work. When you plug them back in, you'll take the square root of a negative number, but I don't think that's going to happen for this one. All right, let's look at 15. So for 15, it asks, which is the apparent solution set for the system of equations? So we have a graph right here, a graph right here. The solutions are going to be where the two graphs, what? Where they cross or intersect, right? So let's look at the 2 points where they cross. So starting on the left side, they cross where? Which x value do they cross at? Okay, so -4 and -1. So those are going to be my x values. They're the numbers that come first. And then for the -4, it would be 3. So +3 on the y-axis. And then for the -1, yep, 0 right here on the x-axis. That's going to be C. Okay. Number 16. So 16 gives us a number line. I'm going to draw it. It goes from -12 to 6. So I'll put -12 over here. I'll put 6 over here. And then we're going to count off by 2s. So this is the number line that they give us, and it looks like they're putting open circles on 4 and -11. So let me change my color to red. We're going to put an open circle around 4 and -11, which is going to be between these two numbers. And we're going to shade in the middle. So the way I like to shade is this. So we're shading every number between -11 and 4. One of the ways we can write that is x has to be less than 4, but it has to be greater than -11 for this to work. So this is the solution to the problem that I'm looking for. So this one is kind of backwards. What we're going to do is we're going to go through each one of these and see which one best matches up. Let's look at A first. I've got x minus 11. The absolute value is less than, greater than 4. My bad. So for this one, yeah, this would be wrong. Why is that? So when you break up the absolute value, what you'll notice is you get these two equations or inequalities, right? If you use a greater than, that means you're going to have an or in the middle. So if I add 11 to both sides, you'll get 4 plus 11 is what? 15. Yeah, that's not good. We don't use 15 anywhere. And over here you get 7. So that's not good. And when you look at B, it's pretty much the same story. So we can't use A or B. So let's check out C and D. I've got 2x plus 7. We'll start off with the greater than. And then we have 15 on the other side. So for this one, we can take the 2x plus 7 out. We can set it greater than 15. Or we can use 2x plus 7 is less than negative 15. And when we do that, we can subtract 7 from both sides. We get 2x is greater than 8. And 2x is less than negative 22. So when you divide this by 2, you get x is greater than 4. And for this one, you get x is less than negative 11. But why is this one not matching up? Yeah. See how x is greater than 4? That would mean you would be going to the right, like that. And since x is less than negative 11, you would be doing this. That's not good. So the only one that could possibly be right is D. So here's what happens. You could have a less than symbol right here. The way that would work is this sign would flip. So you would have less than. This would be a greater than. And then the word in the middle would be and instead of or. So that way, this sign is going to flip at the bottom. This sign is going to flip. And then these signs at the top are going to flip. So what that's going to look like is less than, greater than, less than, greater than. So now at least you're pointing in the right direction and you have the right numbers. So that's why it's going to be D. Okay, let's look at 17. I've got the cube root of 2x minus 5. So that's going to look like this. And then on the other side, I'm going to have 3. This is also a radical equation. And you can tell because we have a radical sign on the left. But this one's going to be a cube root. So it says the cube root of 2x minus 5 is equal to 3. What I want to do is I want to get rid of this cube root. How can I do that? What would I have to do to both sides? If it's a cube root, I'm going to have to cube both sides. So my exponent on both sides is going to be 3. When I do that, whatever's inside the radical is going to come out. I know that I have 2x minus 5 on the inside, the cube root, and then the 3 as an exponent. They actually cancel each other out. So I guess you could do that. But then what's going to be on the other side? What's 3 cubed? 27. Good. So that would just be 3 times 3 times 3. So I get 27 on the other side. Now I can just work on getting x by itself. How can I do that? How can I get rid of this negative 5? You can add 5 to both sides, right? And then you draw your line. After that, the 5s are going to cancel out. And I can bring down my 2x. 27 plus 5, 32. And then I need to get rid of this 2 right here. How can I do that? Yep, divide by 2. So we're going to divide by 2 on the left and the right. The 2's are going to cancel out. And that just leaves me with an x and a 16. So that's going to be inside my solution set. Just a 16. And if you were to plug it back in for x in my original equation, you would see that eventually you get the cube root of 27 is 3. So your answer would just be 16. All right, 18. Says, what are the apparent roots of this equation that's graphed? So when I think about roots, I should also think about what? Roots are the same thing as what? Anybody know? X-intercepts. So x-intercepts are where the graph crosses the x-axis. Where the graph crosses the x-axis. So I want to know where this graph is going to cross the x-axis. So if I have my little graph right here, I know that this is going to be the y-axis and the x-axis. I'm looking at where the graph is going to cross the horizontal axis. So basically, I'm looking here and here. So going back to our graph, where does it cross the x-axis? What do you think? Yeah, -1.5, which is -3/2. So I'm going to choose C. -3/2, +1/2. And you can actually take these roots where they cross the x-axis, and you can build the polynomial back again. So when you think about roots, they're kind of like tree roots. They come out of the ground, right? If you think of the x-axis as the ground, that's where the roots are going to be. Okay, last question. If no denominator is equal to 0, what is the solution set? So I've got the first fraction is on the left side. So for number 19, I've got 3x minus 4. That's going to be the numerator. My denominator is x squared. On the right side, I have 3/2x. When I set these fractions equal to each other, that means that the numerators must be equal and the denominators must be equal. This is called a rational equation. Okay, so there are two ways you can do this. You can find a least common denominator, like I did for the first question, or you can do cross products. Cross products. And that's probably what I'm going to do for this one, since I've only got two fractions. So what I'm going to do is I'm going to change my color to red and blue. And I'm going to draw a line from the first denominator to the second numerator, like this. So it's going to be kind of a diagonal line. What I'm going to do is I'm going to multiply this by this. 3 times x squared is 3x squared. And that's going to be equal to the other diagonal. So in red, I'm going to draw a line from the top of the first fraction to the bottom of the second fraction, like that. And I'm going to circle the 3x minus 4 and the 2x. And we're going to multiply those together. And there you have it. So let's see if we can solve this. What's the first thing that I have to do to solve it? What am I going to do with this 2x? I'm going to do the distributive property. 2x times 3x. That's going to give me 6x squared minus 2x times 4. That's going to give me 8x. So that's the first step that I'm going to take. Multiplying everything on the inside by what's on the outside. What can I do now? What I want to do is I want to get everything on the right side, because almost everything is on the right side anyways, right? I've just got to get rid of this 3x squared. How can I do that? We're going to subtract 3x squared from both sides. So while they cancel out on this side and give me 0, what happens on the other side? What's 6 minus 3? Anybody? 3. Good. I'll put an x squared beside that. And then I'm going to bring down the negative 8x. So I get 3x squared minus 8x is equal to 0. Okay, so I get this equation right here. Is there anything that these two terms have in common? They have an x in common, right? So we're going to take out the x as the GCF, the greatest common factor. So what I'm going to do is I'm going to divide both sides by x and see what I get. If I take an x away from the 3x squared, I'm just going to have a 3x. But if I take an x away from the 8x, essentially you would just be dividing this. So I'm left with minus 8. So now that's going to give me two different equations. I'm going to have x is equal to 0. That one's already solved for me. The next equation that I'm going to get is 3x minus 8 equals 0. Because I can set both factors equal to 0. And then from here, I can figure out what x is. So I'm going to get rid of the minus 8 by adding 8. When I do that, the 8's are going to cancel out. I'll get 3x is equal to 8. And then the last thing I need to do is divide both sides by 3. The 3's are going to cancel out. And what's 8 divided by 3? We don't know, right? So we're going to leave it as a fraction. So inside of our solution set, we're going to have two numbers, 0 and 8/3. Now for these two answers, which one does not belong? The 0. Yep. So I'm going to mark it out. This 0 is bad. Why is it bad? Okay, so going back to our original equation, what would happen if we let x be 0? What will we get right here and right here? 0. Yep. 0 squared is equal to 0. 2 times 0 is 0. So you would be dividing by 0, and we can't have that. So we already know that x cannot be equal to 0 under any circumstance. So the only answer is this, 8/3. So that's going to be 8.